Good afternoon. I am David Bowman. I'm the Executive Director of the Four Corners Regional Education Cooperative #1 up here in Farmington, New Mexico. And today's session is actually part 4 of a series on using Excel to look at student data and other kinds of data also. However, since we've got a bunch of new people coming in today, I'm going to spend just a little bit of time and run through the techniques that we had in sessions 1 through 3, because they are a bit cumulative. I'm not going to spend time explaining how they all work. We'll just use them, and I'll kind of talk through them. But if you need me to stop and provide a little more explanation about one of them or multiple, just for sure let me know, and I'd be happy to do that. And of course, you can always go back and look at the other videos as well, but I'll be happy to stop and explain as I go along. This session is primarily to start looking at some statistics, start looking at not just how do we count and pull numbers out of our data, but actually do a little bit of analysis around those numbers and see what they tell us, right? One of the things that we know in today's education environment is everybody's got numbers and lots of numbers about everything. So the big question is, what for? So what? We got a bunch of numbers. What do we learn from those numbers? How do we get information out of our data? And then what kind of analyses can we perform? Just some simple analyses that we can perform that actually help to inform what we're doing, help us decide what we've done, and perhaps even what we need to do next. So that's going to be the focus of this hour that we have to spend together. So with that being said, and all the caveats in place, I'm going to go ahead and just share my entire screen. So you'll see right there is the direct URL, which takes you to our webpage where we're posting these videos. This one is also being recorded, and I anticipate that it'll be available online on Tuesday, probably late Tuesday. Surprisingly, it takes a very long time to upload stuff to YouTube, and these are kind of longish videos. So late Tuesday, early Wednesday, it should be there available to you. So with that being said, let's jump into it, right? Let me move some things around here. There we go. All right, let's try that. All right. So what I've got for us to play with today is kind of a small set of student data. We've got IDs, we have the gender or the sex of the student, grades, an indicator of whether or not it's a special education student, an ELL student, how many absences the students have, and a test score for each of those students. And we're going to start with these, pull some information out, and then play with that information a bit and see what we can learn from it. So just to kind of run through the prior techniques, the first thing I'm always going to do when I'm looking at data, regardless, is I'm going to name my ranges, because it's going to make everything else so much easier to do. So I'm going to take a moment and I'm going to name each of these groups, each of these categories of data by something that makes sense to me. So we're going to call that group, I've selected it, we're going to call it student ID. We're going to make this one, and we're going to call that sex. And you see I'm just highlighting, I'm typing the name that I want. And now that entire range has a name that I can use when I start writing some formulas. One of the reasons why everybody's eyes start to cross and just go wonky when they're looking at formulas and doing stuff, nothing makes any sense. Well, it doesn't make any sense unless you give it a name that makes sense. So that's what I'm doing right now. So let's get the group of data called absences. ABSENCES. Okay. And I'm giving them names that make sense to me. And over here is scores. So now whenever when I want to pull that type of information out, I can just refer to it by name, and Excel will already know where to look in the data for that information. Makes it all easy. All right, so just to walk through the prior techniques for the benefit of folks, and like I said, we've got an hour. I don't want to spend more than 20 minutes walking through the prior stuff, honestly, because we got some really interesting things to do. But if you want me to stop and explain what, how, and why on any of these, absolutely feel free to jump in, and I would be happy to do that. All right, so let's just do some basic counting first. First question: how many students do we have? I already know. Actually, I've forgotten. It's actually 40. Okay, but there's an easier way to do it than that. So let's do it the easy way. People tell me I'm efficient, but the fact of the matter is I'm actually lazy. So I find easier ways to do things. So that formula for counting, like how many items, the formula is count A for all, and then just where am I counting for the data? So let's do equals count A, count all, and then it's going to ask me where are you counting? And I don't have to put in B5 through B45. I can just say in the range student ID.
Never mind, I got there.
Okay, great. So I did a count all. How many cells in that range have something in them? 40. So we've got 40 students. A lot easier than doing it manually, right? Okay, so that's kind of interesting, but not really very interesting, to be honest. So let's start breaking it down. How many males do we have? Now we have to actually impose some conditions on counting, not just how many, but how many meet a certain criteria. And the formula is going to be count if. And Excel is going to ask me two things. Where am I looking? And what's the criterion I'm looking for? So it's going to look in the range, tell me how many times that criterion is met. So, is that a question or is that just background chatter? Okay. So count if. Come on, Bowman, you can type. Count if. Where am I going to look for the data? And what am I looking for? Well, I want to know how many males, how many females. So I'm going to look in the range called student sex, which you see is highlighted now in the data. And what am I looking for? Excel is amazing, but Microsoft as a company has lousy grammar. So it's asking me for the criteria, which is plural. It should be criterion, but I'm going to give them a pass because the product Excel is amazing. So we'll forgive them for their poor grammar. Now, I could say, tell me how many times does M show up? And I can just type it in manually, but there's an easier way. Again, instead of looking for the M, I'm going to click on that cell right above it, K8, and whatever is in that cell, that's what we're looking for. In this case, male. Oh, we have 21 males. The reason why I do that, instead of typing in the M, I can now take that formula, copy it to the right. So now instead of looking up one for males, it's going to look up one for F, female, and tell me there are 19 of those. And of course, together that's 40. So that makes it very, very simple. And we can even break it down to quite a bit more than that. So that's only one criterion, count if. If I want multiple criterion, same thing. But I'm going to use count ifs, IFS. And the formula is almost exactly the same. Instead of count if, I'm going to add an S to it, count ifs, and range criterion. What's the next range? What's the next criterion? And so on and so on. I believe you can actually have up to 256 criterion, and it will count the number of times all of them are met per line, which is kind of nuts, right? That's, I don't know why anybody would need that. And if you have that many criterion, then I don't know, you need a change in lifestyle or something. So what are we looking for? We want how many ELL students are also SPED students and are also male. So equals count ifs. What am I looking? First range, well, how many ELL students? So I named that range ELL, and I'm looking for the number 1 to indicate ELL. Then what's the next? Well, I also want how many SPED students, and again, I'm going to look for the number 1, because over there in my data, you see that a 1 is for yes, a 0 is for no. It could have been anything as long as it's consistent, and that's what I would look for. In this case, though, everything's 1 and 0. They are or they aren't. So that makes it kind of easy. And then what am I looking for next? So I'm looking for ELL SPED, but I'm also looking for the student sex. And again, I'm going to simply refer to whatever is in the cell above it. That's what I'm looking for. Oh, 2 male ELL SPED students, copy it to the right, and 3 female ELL SPED students. So I'm able to instantaneously, or close enough, look through all the data, 40 kids, and in nothing flat, pull out some very specific student counts. So this is a review, so a little quick, and I apologize, but certainly stop me if you need me to slow down or re-explain how one of these formulas work. This one is actually going to be a bit trickier. We need to do something a bit different.
Students, if you're after school, we have after school today. After school tutoring is going to happen today.
Okay, that was fun. So ELL, that's, yes or no, right? So that's easy. Male and female, that's easy. But that above 500 is a bit trickier. And let me just take a moment and show how that's going to work. But let me just get a general writing tablet here. There's my notepad. Let me just get rid of that. Okay. So because we want, am I on the brush? We want to know greater than 500. We're actually asking for 2 things. Excel has to determine if it's greater, and it has to look at the actual score. So 2 things. And the way that we make those into one criterion, see, they've got me doing it now, is we have to put quotations around them. So our criterion is going to look like that right there with the quotation marks around it in order to combine both of those into a single criterion. So let's do that. Other than that, it's the same process, easy peasy. So equals count ifs, first criterion range, ELL, 1, sex. Again, I'm going to just refer to the cell up there by clicking on it. And then score, and the criterion, and here come my quotation marks, greater than 500. And let's see if it works, yeah? It did not. What did I call this? Oh, I called that scores. That's why. So I got something called a name error because there's no named range called score. Oops. So it's like, hey, we're looking, can't find it. So I'm going to just go back and add that to my formula, make it scores, plural. And now I see it highlighted in the data over there, so I know it recognizes it. And let's see, 2. 2 male ELL students with scores above 500. Let's just copy it to the right. And 7 female ELL students with scores above 500. So apparently the girls are rocking it and the boys are catching up. All right. So that's just counting. Let's make it even easier, right? Sometimes we don't need to know everything. I just want to know, like, above 500, above 400, above 300. And I want to be able to change it on the fly without having to rewrite the formula. And we're going to do that with data validation. And let me blow it up a little more. So right here, in this top cell right here, I'm going to do a little data validation that's going to give me a drop-down list where I can select the threshold score I'm looking for. And then I'll write the formula to simply refer to it. All right, so let's do that. Let me come up here to data, and somewhere up here, there we go, data validation, kind of under the middle. Data validation, what can go in that cell? What is allowed to go? Well, instead of any value, I want a list, and it can only be a list. Now here, I can either refer to a list that I've created somewhere and given it a name, or I can just write them in. In this case, I'll just write them in. So 100, 200, 300, 400, 500, 600. Let's keep going. Why not? 700, 800. All right, so that's the list of acceptable values for that cell. And I'm going to hit OK. And you'll see I now have a drop-down list. One little quirk of Excel that I don't understand, but I've learned to live with it. When you do a drop-down list like this, you're limited to 8 values. Well, you can put as many values as you want, but it's only going to display 8 at a time. Once you get past 8, you get a little scroll bar, and then you can keep scrolling to find what you want. But 8 will display there. All right, so now I can use my pull down, put whatever threshold number I want. And now I'll write my formula to refer to that. So if I change that, the results are going to change automatically as well. But from here on out, it's the exact same thing. So equals count ifs, ELL is 1, sex is whatever is up there, oops, comma, oops. Sex is that, and score, we're going to have to do something tricky here. Because before I just said greater than 500. But now I need to say greater than, and then the reference to that cell above it, which is a little trickier.
So you open the gate, the walking gate.
If that was a question, I didn't catch it. Excuse me. We're having air in Farmington apparently, and it's going in my nose. So we have to do something a little bit different here. And the reason why I highlighted in green is because this is a new thing. Here's what's going to happen. Let me get rid of all that. Okay. So previously I said, well, just look for greater than 500. Okay. And we put in the quotations. But now we still need the greater than, but here we're going to put some kind of a reference, which is different than typing in a number. I need to be able to get out of this block of information called greater than 500 and send Excel off to a different place, kind of like what we did for males and females. So we have to do even something a bit trickier. If we're going to say greater than, less than, greater than, equal, not equal to another cell reference, I still have to get that greater than in quotes, but then I have to get out of the quotes and send Excel somewhere else, which means I need to be able to mush a couple of things together. for Excel to be able to do that. So we still have this greater than symbol. And I'm going to put that in quotes, just as I did before. And over here is going to be, I don't know, whatever it is. Let's call it J25, okay, as a cell reference. Whatever's in J25, that's what I want. So I need to combine this with this over here. And the way that I do it is I use an ampersand. This and this, combine them together into a single thing. Unlike what I did with the numbers, I've got to get an Excel cell reference combined with that greater than. And it's the ampersand that does that. So it becomes greater than J25. It's going to merge them together into a single criterion. And that's how we're going to make this technique work. And it's going to be the same thing. If we did like greater than or equal to and J25, or less than ampersand, and then the cell reference, like that. And it's that ampersand that's going to join them together. It's actually a process called, this is a good one for Trivial Pursuit, it's called concatenation, but basically what it's doing is it's smushing them together into a single thing, or it's merging them. So let's do that. As soon as I find where we were. So here I am, ELL1, sex is whatever's up in K12, and the score is going to be quotation greater than into my quotation, and take that greater than symbol and merge it with whatever's in the cell directly above it, which in this case is K15. And at this point, what we do is we cross our fingers. I did the same thing again. You know, the problem is I've renamed that scores. I've named that range scores, and I'm still thinking, give me the score. So let me just add that S back in there. And the answer is 3. We have 3 male ELL students with scores above 400. But now look, here's where it gets cool. I can simply change this. And it's still 3. I can change that. Above 100, it's 4. So I can choose a different threshold value here now and simply refer to it in my formula. And on the fly, I can recalculate that count. 400, there are 3 of them. 600, 2 of them. We're losing some kids here. 700, still 2. 800 or above, 2. So by doing the drop-down list, I don't ever have to rewrite the formula. I can just change the value in the drop-down list, and it will recalculate for me below it. It could have been male, female there, or first score, second score, whatever criterion is going to change. You can throw it into a drop-down list. The formula will recalculate based on it. All right, so that's a new little fast trick for you today. All right, so let's do some very simple things, and let's hope that Bowman can remember the S on scores again. Quickly, average. If you want to get an average value, it's quite simple. It's just average, and then what's the range where we're looking. So we want the average of scores. So give me the average of all of those. And this is kind of like count A, just everything that's there, use it. And the average score is 538.5. But that's not very specific, so we can start pulling out specific pieces. Like in this case, well, I've got 4th and 5th grade students. I want just 4th grade. So where am I going to look? And what's the criterion for which I am looking? works almost exactly this, well, it works exactly the same as count if. It's just average if in this case. So equals average if. Now, you'll see there's an extra piece that's being asked.
Great.
And it's optional. And it's called the average range. So the way average if works, it says, look in the range and tell me what the criterion is. So I could say average all the scores above 500. Look in scores above 500. Okay. Or what is more useful is to say, look at the criterion over here, find the kids that meet that criterion, and then go over here to this other set of data and average out those numbers. Like in this case, I want 5th grade students. So I need to look under grades for 5th grade, but then go over to scores and average up their scores. So there's another piece we can add to this called range to average. Where am I going to look for a criterion? What is the criterion? Once I have found it, what scores, where are the scores or the values I need to average up? Equals average if. So here it's going to be grade. I'm looking for a 5. And the data I'm looking to average is over under scores. 5th grade students averaged 499.1. Which is actually kind of interesting because it's less than the overall average, which means, just out of curiosity, those are 5th grade. How do the 4th graders do? Average if. Grade for scores. My guess is it's going to be higher. Sure enough, the 4th graders have a higher average score than the 5th graders. That is kind of curious. And then the average score for EL is exactly the same. So just like we have count if and count ifs, over here we've got average if and average ifs, where I can have multiple criterion. So it's going to look almost exactly the same. Except in this case, because we already know there are multiple criterion, and we've got to be able to string them up forever. Here, we're going to do range to average first, and then range for the criterion itself, range, criterion, et cetera, et cetera, et cetera. It's going to look like that. So first, we start with where are the values you're going to average up after you meet all the criterion. So in this case, I'm looking for, let's start with, where am I looking? I'm looking in scores with the S. All right, what's the first place where I'm looking for the criterion? Let's call it sex. What am I looking for? I'll just click on the M right above there. And I'm also looking for student grade. And what am I looking for in grade? I'm looking for what's over there to the left, that. Average score for 4th grade males, 535.1. Now, as I mentioned, I'm fundamentally lazy. So I'm looking for easy ways to do things. The last thing that I want to do is have to rewrite my formulas over and over again, ever, if I can at all avoid it. So I could simply drag that formula under females, but there's a problem. When I move from column K for males over to column L for females, it's going to go from this column, move it over to that column for females. But the problem is I'm also referring to that grade 4 on the side, and that's going to move also. So I've got to do something a little bit different to say no matter where I move this formula, right, left, up, down, student sex is in column 20, in row 26, no matter where I put the formula. And student grade is in column J. So even if I move it across, I still need to look back in column J. So I need to tell Excel, when I'm looking for the student sex, always look in row 26. And when I'm looking for student grade, always look in J. So we need to do something called absolute references. And obviously, this is a very simple little table here. And frankly, it wouldn't take much time to just rewrite the formula a bunch of times. But I don't want to do that. I want Excel to do the work for me. So I need to tell Excel, when I move this formula around, student sex is in the same place and student grade is in the same place. So we have to talk about something called absolute references. And here's how they work. Let me hide that away and take a look at this one. So this is how formulas typically work. So let's say I'm saying, okay, right here in Notepad, references. Okay, so let's say I'm telling Excel, all right, when I write the formula here, I want you to go get the value down there, which is in B7. And if I move the formula over, like I did to go from male to female, you'll see that B now becomes E, which is here. And it's going to say E7 now. It automatically is going to update, and it's going to now refer to this cell over here because it's doing something called relative referencing. Like relative to where the formula is, where do I go? How many rows do I move and how many columns do I move to go get the value I need? And if I move the formula, it's still going to go the same number of rows and the same number of columns to find the value. That's how we did the male and female. We just moved it over one, instead of looking in this column, it now looked in the next column over. And if I take this formula here and I move it all the way down here, it's still going to say, look down 1, 2, 3, look down 4 rows and get that value. So wherever the formula is, it's still going to go the same number of rows, same number of columns to find the value it needs. But in this case, I need the student sex is always going to be in that same row, 26, whatever it was. And if I move the formula around, the student grade is still in the same column where we started. We can't go and look for it in a new place because it doesn't exist somewhere else. So we have to tell Excel, always go to the same cell to find the value, no matter where I move the formula. So we do something called absolute references. So here's my, what do we got? We got row 20, column B. So this is saying, okay, look down in B24, which is right there. And if I move the formula over, I don't want to go down 4 rows. I still want to go look over in B24. And if I move it down like I did previously, don't move the target cell, I still need B24. And the way we do that for Excel is we add this in front of the column, and we add this in front of the row. So this says, no matter where I put this formula, always look in that column. No matter where I put the formula, always look in that row. And the nifty thing, which is what we're going to use, the nifty thing is that I can just say, here my B24, I can say, all right, the 24 can move, that's fine, but the B has to stay the same. So no matter where I put my formula, column B is always going to be column B, but 24 can change. Or I can do it like, there's my B24. Okay, B can move, I can move columns, that's not a problem, but row 24 must stay row 24. So I only put my $sign instead of 24. So no matter where else I move it, you must look in row 24.
Mhm.
Here's how we're going to use that. Because as you see with my little table here, I'm going to be moving formulas across and down. So student sex, which is currently K26. No matter where I put this formula, the student sex is still in 26. So the $sign will go in front of the 26. And student grade is always going to be in column J, no matter where I put the formula. So I need a $sign in front of the J. We can move the formula, but J is going to stay J because that's where student grades are. Now, why is that useful to me? Because now I only have to write the formula one time. I can move it across to the right, and I can drag both of those and fill down, and my table is now done. So you'll see this is referring to K26 for the sex and J27 for the grade. This one is now still looking in row 26 for the sex, even though I moved it down, and it's still looking over in column J for the grade. So by making either the row or the column absolute, I can now move this formula around wherever I want to, and it's going to find the right information. I only have to write the formula one time, and Excel will do the rest. So that's cool. Let's skip sum product for now. There's a really good explanation of sum product in the first couple of videos, so we're going to hold that for now. And let's jump to the stats now. Let's jump into the stats. So we do all this counting, and that's all that is, counting and averaging, and then, it's pretty basic stuff. But let's get to the actual stats now. Let's get to the analysis now. One of the first things that I'm going to do if I'm looking at any kind of averages is I'm always going to ask the question, what's my standard deviation? Because unless I know how spread out the data are, the average is meaningless, right? I can come up with an average value for anything, but how well does that indicate the general population? And let me show you what I mean by that. Let me pull over here to standard deviation. So here we have 3 bell curves. If you'll notice, the blue one has a standard deviation of 5. Let me actually pull that up. Okay, has a standard deviation 5. And all of the values are pretty well clustered around the average. So that average is a pretty good indicator of how kids are doing in this case. Okay. The next one has a standard deviation of 10, and they are a lot more spread out. So maybe that average doesn't tell me much about how well the kids are doing, because they're kind of all over the place. And then even worse, we've got the standard deviation of 20, and look at this. Those are so spread out that average doesn't really tell me anything at all. So when I'm looking at student data or any kind of data, and I say, well, what's the average score? Well, unless I know that standard deviation, I don't know whether or not I can use that average. Does it mean anything or not? Because if the data is so spread out, it's not a good indication of how that population is doing. So that standard deviation becomes very critical for understanding the value of that average. Turns out it is really, really easy to do in Excel. Once upon a time, I had all the formulas memorized, how to do standard deviations, and it's a good show-off piece, but who's got the time for that? Excel will do it for me. So what's the formula? Simply equals ST, standard deviation, and what's the range? And Excel will do all the work for me. So let's see what it is. Standard deviation of scores. The standard deviation is 329.9 points. That is actually a very large standard deviation. But you'll notice I labeled this sample and population, because when we run standard deviation, what we're assuming is that we have a sample set of data. Like we've got 30,000 people in town and we have data points for 15,000. So it's a sample of the overall. Well, if we have 100% of the scores like we do for these kids over here, we're not looking at a sample of the population. We've got the entire population. And the formula is slightly different, both the way it's calculated in the results. But if we've got the entire set of population, we don't want STDEV. We want to add a P in there, which tells Excel this is the entire set of data. It's not a sample of the data, we get all the data. So P, let's see if it gives us a different result. It does. It's actually a little narrower. The standard deviation is a little smaller than for the sample. Okay. Honestly, with that size, I mean, we've only got scored from 0 to, I think the highest one is 900. So that's actually a really big standard deviation, which tells me the average isn't very valuable to me. Now I can do, to start getting more useful information, I can start subdividing the data and getting my standard deviation for subgroups within my data. Aha. Because that's kind of a ridiculous number, honestly. With an average of being, what is my overall average? 538. That means, we're looking at from 200 to 850 or something like that. I mean, that's almost the entire range of scores. So yeah, all the kids are in there. It is pretty flat, a pretty flat curve. So let's start subdividing it. Maybe I don't want the standard deviation for all the scores, because I got 4th and 5th grade in here. How about just the 4th graders? What's their standard deviation? So I need to impose some criteria to say, don't give me the standard deviation for anything and everything. Give me the standard deviation if we meet a certain criterion. And in this case, 4th grade or 5th grade. So I need to get that word if in there, like average if, count if, right? I need to get an if in there. I know that. If, and I'm going to put in parentheses, if, grade.
Marty, Marta, Martha. Martha, Marta, Marty. Did you get Linda's chat?
Okay.
Okay, just want to make sure. She's like, is she there? Yes, I am.
Okay.
Thank you.
So what have I done here? I have imposed an if statement. If the range is this, if this particular criterion range meets this criterion, if we can meet that criterion, then go get the value in this other range, which is actually range of values to calculate, all right? So I've got an if statement, which is embedded itself within parentheses. If this is true, then go get the values over here. Now, why do I have 2 parentheses at the end? Well, every starting parenthesis needs a closing parenthesis. So here's 1. That's my if statement. It starts with the parenthesis, ends with the parenthesis. And here's my standard deviation, starts with the parenthesis and ends with the parenthesis. So the result is I have 2 at the end. Okay. But that's how we're doing it. So if it meets this, if this is true, go get that value over there. And then calculate the standard deviation on those values. Let's see if it works. Equals. So standard deviation, if, now I want grade If grade equals 4, then where's the range? Scores. And close it off. And then we cross our fingers. If grade equals standard deviation, if grade equals 4, go get the scores. And why is it giving me a name? Oh, because STD-DEV is not right. I stuttered. Just 1D, please. Dividing by 0. What does that mean? That means, if you come across this, it means there were no values that met the criterion, which is a little odd. Let's try it with 5th grade. Equals STDEV. If grade equals 5 or whatever's above it, then scores. So the standard deviation for the 5th grade students is 329.9. And why did it not find 4s? That is very odd to me. If grade equals 4, scores. Failed because it did not find a 4, but it did find 5s. I'm going to come back to that one myself. That's going to bug me all night. But that's what it looks like. If the value in this range is this criterion, go get the score in this range over here, and then give me the standard deviation of all of that. Interesting. It's coming up with a 0. I'm going to have to look into that. All right. We'll skip. We can do the same thing of multiple criterion. I'm thinking that we probably ought to skip that for now. Like we can do like we did before with 4th and 5th grade and males and females and so on. So I think I will bypass that one for now, looking at the clock. Because there's a couple things that I want to do that are super, super useful. One of the things is called frequency. How many times do certain scores show up, right? And can I chart them? Make a little histogram of them? Turns out I can. So when I'm going to run a histogram, I want bar graph showing how many scores are within particular ranges. I have to set up something called bins right here. And a bin is basically the top value of a range. It looks like, let's hide that one. Let's go and grab, we don't need that one anymore. We don't need that one anymore. We don't need that one anymore. We need that one. So over here, you see my bins, and it's the same as I have on the other sheet, the 1, 2, 300, and so forth. What these bins represent is the top value of a range. So when I say the first bin is 100, that means how many scores are up to 100. The next bin is 200. How many scores are above the previous one up to this value? 300 up to 300. 400 means up to 400. All right. And then I always have to add a blank at the bottom. That's, there's nothing because the previous one takes me up to 400, but what if there's something beyond 400, right? I need to have a place to put those values also. So when I'm doing frequencies, I've got to set up bins, which is what you see here. There are my bins, and you will notice that there's a blank at the bottom. These are just, you'll see why I did this, but I went ahead and just manually typed in some descriptions, but this is what we're going to use, right? So you see over there under higher than 1,000, I've got a blank. There's no bin there. That's just like anything that's left over, put it there. Okay. Here's how it works, and it's a bit tricky. So let me blow this up a hair more. Excel does it super fast, and then we're going to graph it, and that'll be very cool. All right, so what I'm going to do is I'm going to highlight or select all of these at the same time because it's going to run the formula for every single one of these at the same time. It can't do just up to 100, just up to 200, just up to 300. Well, it can, but it's a long and it's a tedious and unnecessary process. Okay. So I needed to do all of those at the same time. So I'm going to highlight all of them at the same time. And then I'm going to put in, you can probably guess what this formula is called. I want the frequency, like how frequently your scores in this. So it's just frequency. Now, it's only going to ask me two things. One is, where am I going to get the data? And where are my bins? That's it. So the place for the data is scores. That's where it's going to look. And where's my bins? I'm going to go ahead. I could have just named that. I probably should have named that. But my bins are all these over here. And you'll notice I also selected that blank one at the bottom, which is the overflow. Okay. So where is the values I'm looking for? And where are my bins? Now, because we're doing all of these at once, and we're doing some calculations on an entire range, I cannot hit enter here. If I hit enter, it's going to fail. You've entered too few arguments. All right. Oops, actually, that's supposed to be a comma right there. Okay. It didn't do them all at once because I need to tell Excel calculate across this entire set at the same time. You know what I'm going to do just for giggles? I'm going to name this. Oops. I'm going to go ahead and name this. What should I name it? How about bins? I'll call that bins. Like buckets, like how many go in this bucket, how many in this bucket, right? I'm going to call that bins. All right. Now, where's bins? Too many. Too many. Hang on a second. You get to see me wiggle around. Let me go grab my name manager. And there's bins. It's got one too many in it. It should only be through 18. Okay. Yes. Because those are the actual bins right there, not the extra one at the end. The formula needs to go to the extra one, but there's no bin for that. It's just everything else. Okay, so now let's try it again. Let's see what happens. Equals frequency. Oops. Better than this. There we go. Frequency. Where's my data array? Scores. Where's my bins array? I called it bins, make it easy. In order for Excel to calculate all of these at the same time, I need to make this an array formula. And it's simple to do. Instead of hitting enter on my keyboard, I'm going to hold down Control and Shift together. So I'm holding down Control Shift. And now I hit enter. And you see that it does the entire set at once. If we actually look at the formula, equals frequency, and it's, where's the data? Where are the data, right? And where are the bins? Okay. If we look at the formula, when I did hold down Control Shift and hit enter, it actually put something around this. It put squirrely brackets around it, like that, which tells Excel this is an array formula. Now, if you're doing all this on Google, and I've tried it all, everything we're doing here is going to work just fine on Google Sheets, exactly the same. So for the people that use Google Sheets instead of Excel, don't panic, it works the same. The only difference is when you do Control Shift and Enter, or Option Shift Enter for Mac people, it's actually going to put the word array formula at the beginning of it. It's going to do the same thing. So it looks like that. So if we look at the formula over here, if you can see it, you'll notice that it has the squirrely braces around it to say it is an array. Now here's where it gets cool. And here's why I typed in all of these over here. I'm going to select that. I'm going to select that. I'm going to go to insert. I'm going to go get myself a bar chart. And there is my histogram. And you'll see the labels at the bottom up to 100 from 101 to 102. That's why I did it manually, just to make it clear what those bars are going to represent. And then, on the right, on the y-axis, scores, and on the x-axis are my labels. That's how we do our histograms. Which you have to admit is pretty cool, right? It sure beats counting manually or writing a lot of complex formulas for every single one of those values, which we could have done, but there's no reason to do it. We could have used a count if to do that, but we'd have to do it a bunch of different times, and it's not worth doing. We'll just do frequency, and then we can chart it. Very, very cool stuff. Most of these we're going to skip or have already done, but I want to do 326. We can do correlations. We've already done standard deviations. We've done averages. I want to do something called R2 values. An R2 value for a set of data tells us how closely the data fit a linear trend line. And what that means is, a trend line, a change in this value is reflected by a change in that value over there. So like if in this case we have times and scores, and I'm going to name them. So this is times 1. And this is scores 1. I'll just do these two sets here. So one of the questions I might have is, if kids are taking more time on the test, are their scores going up? If they take less time, are they more likely to have a lower score? Is there an actual relationship of any kind between times and scores? So I can run a correlation, but that doesn't tell me how much of an effect time has on scores. It just says, yeah, they both move at the same time. Okay, one goes up, the other one goes up or down. But it doesn't tell me anything about how the degree to which one variable, time, is influencing the second variable, score. And for that, we need something called an R squared value. And there's a much, much longer explanation of that, which frankly, I'm probably not qualified to even begin to approach. But it kind of looks like this. So if we have a low R squared value, here's our trend line. This R squared value is 14.7. Not that one. I need R squared. There we go. 14.7. Let me get my labels in there. Okay. 14.7, which means only 14% of change in one value is caused by the change in the other value. So in this case, the time that kids take, if this were the value, the time that kids take is responsible for only 14% of the change in the other value, which means the data are kind of all over the place, right? That's a very low value. So one is really not influencing the other very much. We can have a higher value, which is this one over here. This one is 86.5, which means one value has a significant impact on the change in the other value. So the change in one, 18 and 86% of the change in one is caused by the change in the other. And that's pretty good. So when we look at our value, time and scores, I want to know to what degree is the change in time responsible for a change in scores. And I can calculate my R squared value to do it. And frankly, Excel makes it very easy. Equals RSQ for R squared. And then I'm going to put what's on my y-axis, or one variable, and what's on my x-axis for the other one. And it will tell me to what degree are the data in the y-axis responsible, or to what level of effect do they have on the change in the other axis. So in our case, we're looking at time and scores. You know what I'm going to do? You can make it better. Hang on. Let's do this. This is time 2, and this is scores 2. Okay. I mean, this is one of those questions we always have in education. We have given, we're looking at it right now in the state legislature, talking about changing the amount of instructional time kids get. Is that change going to result in differences on state assessment scores or not, right? To what degree is instructional time reflected or responsible for changes in student outcomes? It's a big question. And it's our R2 value that answers it. So let's figure it out. I'm gonna do the time 2. So let's do time 2 and scores 2, because I already know the values better. So equals RSQ. What's the independent value, or my y-axis? So that's times time 2. So that one's going to change. How much effect does it have on the other one, which is scores 2? $74, or 74.7%, which means the change, 74.7% of the change in scores is caused by the change in time, which is pretty good. It's not exceptional, but it does mean that time is having a significant impact and is responsible for the majority of the change in student scores. And it's the R2 value that does it. Check this out. Let's drop a little graph in there, shall we? So I've got times and scores. If I'm going to plot these, I'm going to use a scatter plot. Just give me the data points on the y and x axis. No bars, no lines, just where are the data on the graph? Okay, here they are. So you see across the bottom, the x-axis, time, y-axis, scores. We can switch them, which will actually match the formula, but the result's the same, so it kind of doesn't matter, honestly. Let me add a trend line. Let me display the R. You might have seen this, like if you're doing a linear trend line, it says display the R squared value, right? That's what it's calculating. And there is my 74.7, or the change in time is responsible for 74.7% of the change in the scores. So obviously there's some other effects that are having an influence as well, but time is responsible for 74, 3/4 of the change in the scores. And that is essential to know. I'm doing this in my classroom. What effect does it have on student scores? So if I know what my X and my Y are, I can simply calculate, I can plot it. But ultimately what I want to do is I want to calculate that R scored value. And that tells me what is the actual result of something that I have done for these kids. So we're a couple minutes over. We skipped a few things. I might actually just sit around tonight and do another video on a couple of the pieces like norm distribution and stuff like that. But those are the big ones, all right? So, so I hope this is valuable because it actually got us to the point where we can answer some very important questions about our student data, and we can answer some very important questions about what is the effect of what I am doing with my kids on their understanding, on their mastery of the content, on their outcomes. And as you see, Excel makes it very, very simple for us. So that kind of brings us to the end. Just to wrap up, I'm David Bowman again, the Executive Director for the Four Corners Regional Education Cooperative number 1. The video will be available on our website at the link that I showed you at the beginning, probably Tuesday. But I will mention this. I know this is kind of heady stuff, and we sort of race through it at a gallop, right? So if you're sitting around over the weekend, man, like that was so cool. That was like the most amazing thing, but I have no idea how he did it. And you want to reach out and say and ask questions or other things we can look at around the data. I am more than happy to answer questions, assist. We can do a little screen share, whatever the case may be, because I know what kind of power this has for what we do in education, and I just see it as a part of my mission to help other people be able to look at their data and do some important things with it. So feel free to reach out to me. But with that, I will bid you all a good day, and thank you all so much for being here. Everybody take care.